Live. Hola.
Good morning, YouTube.
Good morning, the YouTube world. The online world. Do I like this with you, right? No. Honestly. I don't have the energy to do that this morning. Alright. So yesterday, we saw ways to solve multivariable, nonlinear multivariable equations. Okay? What we're going to do today is we've got a few examples here. We're going to go through and take care of these. We're also going to go learn a fourth and final method to add to our repertoire today and round out these nonlinear things. So we'll be done talking about these today. They're not that difficult with you guys. I'm sure you guys know that by now. One quick announcement though for tonight. I believe it says so on Canvas. I want you to basically catch up. That is, any outstanding stuff you owe me, okay, and I will put the worksheets and things or the quizzes and stuff up on Canvas so you have an action. I want you to do it tonight for homework and turn it into me tomorrow. Okay, that way we're all caught up. Grade period, ends Friday, so that helps me out a lot if we're just all caught up. Okay. Plus, I figure just do it as a take home, turn it in. Okay. Huh? Friday? I know, it feels that way, right? Spring trimester is like super short.
It is.
So corrections.
It goes by.
So like corrections, things like that. Please try to do that. And that's the only thing I'm going to have assigned for you tonight. Okay? Basically, just to catch up with all that stuff. Okay? Because what we'll do is there won't be a new. We're not really doing anything new today. We're just making sure we understand this. And tomorrow we'll hit the ground running with parametric equations. Okay. All right. So worksheet. We had 5 of these guys to do. They should have been fairly straightforward. It's basically we're going to solve these nonlinear multivariable equations. Okay. Basically solve the following systems. Give all solutions to x and y if possible. Remember, sometimes these things don't work, and when they don't work, you kind of want to note that be the case. All right. Let's start off with number 1. I'm going to go ahead and just bring it up here. Number 1, we've got. Got to keep both here for once. Okay. We got xy is equal to 4. That x squared plus y squared is equal to 8. Okay. So xy equals 4. That's actually a rational function. Okay, when I clean it up, if I were to rewrite this as y equals 8 over x, which if you remember is just a rational function. So it's the one that has the two troops like that. Okay, x squared plus y squared equals 8. What's that shape right there? You should know. It's a circle. Thank you. Okay, it's an easy enough circle. Okay, so basically, what we're going to want to do here is, because this bottom one is x squared plus y squared equals 8, the best way to try to handle this one is to do it by substitution. That is, get the top one, solve the top one for x or y, and then stick it in the bottom one to solve. Everyone got that?
Sure.
All right. So I like having things be y equal because that's what we're used to. So I'll rewrite this top thing as y equals 4 over x. Any questions there? It's fairly straightforward, right? Now I'm going to plug that in to this down here, and that gives me x squared plus 4 over x squared, whoops, I haven't squared it yet, excuse me. 4 over x squared is equal to 8. Any problems with that so far? Okay. Now this is going to require a little bit of cleanup. First thing I'm going to do is I'm going to subtract x squared from both sides and get this by itself, okay? I'm also going to square this. So when I square it, it becomes 16 over x squared equals 8 minus x squared. Any problem with that? Shouldn't be. Now, finally, to finish this up, I'm going to multiply both sides by x squared to get it out of the denominator here, okay? That gives me 16 is equal to 8x squared minus x to the 4th, okay? And to finish this off, I'm going to move that 16 back over to get this to be 0 equals negative 16 plus 8x squared minus x to the 4th. Okay? Everyone see how that works right there? Is that any problem with that? There should be no problem. Okay.
Wait, so what are we trying to find again?
What we're trying to do is, we're just cleaning up the equation to get to something that we can solve. Okay? Now you might say, well, x to the fourth, I don't know how to handle x to the fourth, right? Well, actually, you totally do. Okay? This right here, what does it look suspiciously a lot like? A quadratic equation, right? It's thing squared, thing in the center. Okay? This is a quadratic equation. In fact, with a quick rewrite, I could rewrite this as 0 equals minus x to the fourth minus 8x squared plus 16. And does that factor? What gives me 16? Multiplication-wise. Negative 4 times negative 4, right? And negative 4 plus negative 4 gives me negative 8, right? So this thing can actually factor to x squared minus 4 squared, okay, with the minus sign out in front, okay? But wait, x squared minus 4, can that factor?
Yes.
Absolutely, doesn't it? What does x squared minus 4 factor to?
X minus 3x.
Okay, it's little things like that that you really need to look for, okay, in equations, all right? Because we had something that looked awful, x to the fourth, oh my god. But really, it's no different than a quadratic, and with just a few little algebraic tricks, we're able to get it down. So what are my solutions here?
Minus 2 and plus 2.
X equals 2, and x equals minus 2. Those are my x coordinates. Do you have a question?
Can I answer? Sure.
Yeah, go for it. Okay.
It wouldn't be like, there'd be no, because it's squared, it'd be like nothing. X equals 2, x equals 2. It'd be nothing. Like, what does the squared do then?
That squared?
Yeah.
I does nothing.
Okay.
Okay. Because we're still finding this the usual way. What makes that equal to, what basically will make this thing equal to 0? If I pop in 2, all that becomes 0, right? If I pop in negative 2, all that becomes 0, correct? So those are my only two solutions here, okay? That squared, all it means is that I've got 4 of these, basically. I've got x minus 2, x minus 2, x plus 2, x plus 2. Okay, but is that big of a deal? No, there's still only 2 solutions there. Okay, they just each have a multiplicity of 2. You remember that, so they balance. That's what they do. If you were to graph this, it could be a W. Okay. Anyway. But there you have it. So 2 and negative 2 are x's. Now, the full directions are where to fall for x and y. Okay? So what I'm going to do here is if I've got x to be 2 and negative 2, I come up right here and stick 2 and negative 2 into this to solve for y. Okay? It doesn't matter which one you choose. Either one should give you the same answer if you do things correctly. Okay? So, putting 2 in here. Okay? So, when x is equal to 2, we're going to have y equals 4 over 2, which is 2. And when x is equal to negative 2, we're going to have y equals 4 over negative 2, which is negative 2. So, my solutions to this, my answers, I have one at 2, 2, and I have another one at negative 2, negative 2. Okay? And those are the solutions to my 2 equations. Any questions there? Okay, if I wanted to check to actually make sure these are the right answers, what do you think is the easiest thing to do?
Blot it out.
I could plug back in, make sure they work for x squared plus y squared equals 8. Do they? Yes, they absolutely do. Okay. The other thing I can do, you said plot it out. What do you mean by that? Graph it. Just take a look at what the graph looks like. Graph it. What, the wasp is already in here? Yeah. Don't worry about that damn wasp. Oops, it's 4.
Just wants to learn some math.
Can you? Okay. Oh, that's weird. Whoa. What x squared plus y squared equals 8. Okay? And if you look, 2, 2 is 1, the other one, hey, give me the other one. Bastards, and I give you the other one. Anyway, the other one's clearly down here at -2, -2.
Ooh.
Okay. Everyone see that? So the graph confirms that this works just fine. Okay? All good? Alright, excellent.
Pretty cool image.
Yeah. Alright. So, next one we're going to look at. Y equals x squared plus 1 and 2x squared minus 2y squared equals -2. Now, this one actually, I'm going to go ahead and I'm going to do this the fourth and final way, the way that we didn't mention yesterday, okay? So let me go ahead and write this one anew. Whoops, go away, shoot. We've got y equals x squared plus 1. What type of shape is that, everybody? A tragedy? 2x squared minus 2y equals -2. Now, what's this top shape here? That's a...
That's just a line.
Is it just a line?
That's a
Parabola. It's just a regular parabola. Okay. Okay. This bottom one here, by the way, if I were to pick it up, what do you think it's going to be? Is it?
Or,
Is y squared?
no.
No. So it's just a parabola again. Okay. So it's actually just two parabolas here that we're just seeing where they cross each other. All right. This is already set up for me to be able to do it by substitution. Okay. I'm going to do this one a slightly different way. I can easily set these two equations equal to each other. It would take a very easy, quick rewrite of the bottom one to make that happen. But instead, I'm going to show you a fourth way to do this. So yesterday we saw by substitution, by setting them equal to each other, and by graphing. Today we're going to look at the elimination method for doing these, because you can do a few of these by elimination. Now, there are some requirements. First, okay, you really want to only have, like, when you do elimination this way, you're trying to get rid of just one thing. And you only want there to be one variable to get rid of completely, okay? So this is going to work because I can get rid of the y's or I can get rid of the x squares, okay? If I had, for example, y squared and then y in my equation, I wouldn't be able to do elimination on the y's because there's too many y's. Likewise, if I had an x squared and an x in the equation, I would have too many x's and couldn't do it, okay? So this one is one of the few cases where elimination will work on it, okay? So what I'm going to do is I'm going to set these up for elimination. I'm going to rewrite this top equation so it works by elimination, okay? All I'm going to do is basically switch the y and the 1 in the equation. So this is going to become x squared, let's write this nicely, okay, minus y equals -1. Everyone see how I just rewrote that? All good? Just rewrote it, okay? All right, now let's set this up for elimination. Okay, so I'm just going to make things nice and clean. We've got x squared minus y equals -1, and 2x squared minus 2y equals to -2.
Can't you just divide 2 out of both of those? Or divide 2 out of the lower one?
I can't. I don't want to do that right yet. Okay. And actually, if I did that, what am I going to? Well,
And you get the same thing.
I'm going to get the same thing, which spoils what I'm trying to do here, guys. All right. What am I going to multiply this top by?
2.
Okay. By just 2, right? If I do that, I should, or -2, excuse me, by -2, I should be able to cancel things out at the bottom, right? Okay? So all of this then becomes minus 2x squared plus 2y equals 2, and then 2x squared minus 2y equals -2. And what happens when I add them all together? I get 0x squared, 0y, and equals 0. So I just showed that